Has it been a while since you've looked at any trigonometry? Probably a few years since you last took pre-calc, or maybe you just need a quick refresher. Well, in this video, we're going to go ahead and just go through what the classical trig ratios look like, how to use them, how to compute them if you need them. Let's just go right into it. This should be a very quick one. So we're going to go ahead and just start out with what you would normally see. Okay, we're going to start out with a right triangle. Okay, so here's our right triangle. Okay, right angle is marked there. And I'm going to go ahead and label these sides A, B, C. Now, where A and B are doesn't really necessarily matter, but for right triangles, if you remember from classical high school geometry, we call that the hypotenuse of the right triangle. And then, of course, alarm bells might be going off. What do you immediately think of? And that's the Pythagorean theorem. And Pythagoras is usually where you start. So the Pythagorean theorem relates those sides of the right triangle in the following way, where you have the usual relation a squared plus b squared equals c squared, right? The sum of the squares of the two legs is equal to the square of the hypotenuse. Okay, this is how we find out lengths of sides of right triangles. And we can, of course, rearrange this to solve for any other side. Okay, so for example, if we want a, we do a bit of algebra here, right? Subtract b squared on both sides and then take a square root. We'll get that a is equal to the square root of c squared minus b squared. But take note that this is not the same as c minus b. Square roots don't work like this. You gotta evaluate the stuff on the inside first. Okay, so c squared minus b squared, get that number, take the square root, and then you're done. If all you have are variables, you can't simplify this. So you may as well just leave it like that. So just another quick note. All right. Now, when we talk about right triangles in trigonometry, we have to think about it with respect to an angle. So I'll go ahead and mark off this base angle here, and we'll call it theta, okay? Doesn't really matter what we call it. And we have the three basic ratios, okay? These are the three basic ratios. Okay, there are three basic ratios that we talk about in trigonometry. These are like our base ones that we start with. Okay, so we first have the sine of theta, which is defined as the ratio of the size of the side opposite to the angle, so in this case it's A, to the length of the hypotenuse, C. Okay, so sine opposite over hypotenuse. Let's just go ahead and write that in there. Opposite over hypotenuse. You might remember that from high school trig. The cosine of theta is, if you remember, adjacent over hypotenuse. So in this case, it's going to be this leg adjacent to the angle theta. So in this case, it's B divided by the hypotenuse C. That's adjacent over hypotenuse. And finally, the last basic ratio that we have is the tangent of theta. Okay, that's going to be opposite over adjacent, so A over B. Let's write that in there as well. Opposites over adjacent. Okay, and the usual way that a lot of folks remember this is, well, SOHCAHTOA, okay? Anytime you're working with a classical right triangle trig and you have a triangle to reference, we're going to use SOHCAHTOA here. Okay, it tells you what goes where here. And I can't spell. SOHCAHTOA. There we go. Now, just because you are using a trig function in an application, say in an integral or solving an equation, doesn't necessarily mean that you have to think about SOHCAHTOA. SOHCAHTOA is the geometric, so to say, mnemonic that we remember, right? Sine is opposite over adjacent, OH. Cosine adjacent over hypotenuse, AH. Tangent is opposite over adjacent, OA. All right? So those are our three basic trig ratios. Now, of course, we have three more, okay, that we also use, and these are the reciprocals. Okay, let's actually go ahead and zoom out just a little bit to get a little more room here. Okay, so now we also have the reciprocal functions. And these have their own uses as well. So we have the cosecant of theta, which is the reciprocal of the sine. So whatever fraction we get out for the sine of theta, we just flip it on its side. So in that case, based on a picture here, that's C over A, or in terms of positions of the legs, that's going to be the hypotenuse over the side opposite. We also have the secant function, which is 1 over the cosine, and we just flip that fraction, so that's C over B. Go ahead and zoom back out here. So C over B. And that one there is going to be the hypotenuse over the side adjacent. And then we finally have the cotangent of theta, which I'll go ahead and write below here. The cotangent of theta is 1 over the tangent. And that's going to be the side adjacent over the hypotenuse, which according to us, the way we've marked it, B over A. Now, keep in mind that this is for the angle that I have marked as theta on our little triangle here. If I want to do this for a different angle, say this angle here, the complement, which is 90 minus theta, or you can call it something else, alpha or beta if you like, well, then the ratios are going to be a little different. And you can figure out how they're related and what these co-functions do, the sine and cosine, how those are related, right? The sine of an angle is the cosine of its complement, and so on. But you can always go back and refer to this picture. So this is just some of the basics that we need to keep in mind when we are in calculus, okay? And working with the classical trig functions in this way. Because when we start doing integrals and we have to start doing some trigonometric substitutions, we have to remember how these things work. 1, to simplify our integrands, 2, to work with them, and finally 3, to write a nice, tidy answer for our antiderivative. So keep this in your back pocket. We will need this when we actually start doing calculus and start using these in problems.